My viewers all over the world, thank you very much for watching my channel. I remain Salumaj. Let me greet Nigerians happy independence, the 63rd anniversary. Yeah, today we are going to be talking about inorganic chemistry. The last class we spoke about atomic structure, electronic configuration, then orbiter was introduced briefly, but today we are going to do justice to orbiter. If you have not watched my video on atomic structure, electronic configuration, I will advise that you do so before listening to this lecture because I won't go back to that again because I've told us I built what they call it, I lay foundation before building anything on it. So today we are going to be talking about orbiters. Orbiters. Remember when I was talking about electronic configuration, I spoke about the KLMN. I spoke about the KLMNO and so on and so forth shells. Remember, I drew this. In the nucleus, we have the neutron and we have the proton and we have this shell where the electron is revolving. Where electron is revolving is your shell. We have shells. On those shells, that's where your electrons will be revolving. And the first shell is called the K shell. The second shell is called the L shell. The third shell is called the what? The M shell. The fourth shell is called the M shell. Please, I want you to follow me. Orbital representation is very, very simple. Orbital representation is the modern way of writing electronic configuration. We have the arcade way, in which is the one I taught the last class. Today, I want to teach us the modern way of writing electronic configuration, we call the orbiters. So I said the K shell is called 1, the L shell is called 2, the M shell is regarded as 3, N shell is 4, the O shell, and so on and so forth. That is how orbiters are being represented. Please follow me. In each of the shells, they all have their own sub-energy levels. K, and that energy level is with respect to the number of electrons they can contain. Like your K shell, the maximum number of electrons you can find there is what? 2. In your L shell, the maximum number of electrons you can find there is 8. You remember when I was writing 2, 8, 8, blah, 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 blah. That I told you that in the first shell, the maximum number of electrons that can occupy that shell is what? Your 2. Here, I want to bring it towards the orbital level. In your K shell, we have what we call the X energy level, we have the P energy level, we have the D energy level, we have the F energy level. By convention, we know that X can take the maximum of 2 electrons, P can take the maximum of 6 electrons, D can take the maximum of 10 electrons, while your F can take the maximum of 14 electrons. So for this one now, for your K shell, for instance, let's say I have what they call it, your hydrogen. Hydrogen has how many electrons? Just one. Helium. Helium has 2 electrons. For me to write the electronic configuration, don't forget, you say the thing is what? 1. You can enter into what? The K shell. But if you are writing the orbital representation, in orbital representation of energy level, you don't say just 1. You have to show whether it's in X orbiter, whether it's in P orbiter, whether it's in D orbiter, whether it's in F orbiter. So for me to put this hydrogen now, I said the maximum number of electrons in your K shell is what? 2. And your K, each of the shell has its own sub-energy levels that we are calling orbiters. Like this one has X orbiter. Why is it having only X orbiter? Because it can only occupy 2 electrons. Your L orbiter, look at this. For instance, your 8, by the time you break it down, your first shell will take how many electrons? 2. Remaining 6. The remaining 6 electrons will go into another orbiter. That is what we call, like there, where we have your 2, this is your S. Then the second orbiter is your what? Your P. Then you now say this is S2, P6. So we now have this L shell to be taking X and P orbiters. The same thing applies to M. You are going to have X. The way I've explained this, we are going to have P And we're going to have D because this one has maximum of 2, 2, 6, and then what? 10. So, like what we have here, it means that your M shell can take up to what? 18. Then from there, you move to your F shell that can take up to what? 14. But you see the way I'm going to break everything down for us to understand it better. As I was trying to explain for hydrogen, since hydrogen can be found in the first shell, which is 1. First shell, which is 1. It will now be hydrogen in the first shell. How many electrons does it have? Electron is taken as the atomic number. It has only one atomic number. Then you now say, in which energy level can you find this one electron? It can be found in S orbital. So that one electron is on S orbital. So the orbital representation of hydrogen is what? 1s1. First shell, which is the K. Which energy level? S orbital. How many electrons? 1. If I want to write for helium, helium is what? 2. That 2 electrons can still enter K shell. So you're going to have 1, then S raised to power 2. So this is 1s2. So this is the orbital representation of helium, orbital representation of what? Hydrogen. So let's go further on this. Let's say I have, before that, there is what we call the Pascal triangle. Maybe I'll teach that one in mathematics. Now I told us I'm going to combine both further mathematics and mathematics together. So in Pascal triangle, they now use, like I just told us, we have the K, which is 1, we have the L, which is 2, we have the M, which is 3, we have the N, which is 4. Now, so generally, you can have 1x followed by 2x, then P, 2P, followed by 3x, 3P, 3D, followed by 4x, 4P, 4D, and 4F. If you don't want to write it this way, you can say this is 1x, you stagger it. This is 2x, 2P, and this is 3x, 3P, and 3D. Then you have 4x, 4P, 4D, and 4F. The bone of content, the major thing there is that it must form a triangle. Like this one. So has formed a triangle. So the two are formed what? A triangle. So this is now the way to write any of these orbital level of any of the elements. But let me give us a very good example now so that we now use this distribution to explain it further. Let's say in an exam, you are told to write the orbital representation of, let's say, sodium. Sodium Na is what? 11. Don't forget, you still be relating with the old way. For the old way, you can say this is 281. 281. First shell, second shell, third shell. So, but you have to break it down to the orbital level. In this first shell now, you have, this is like 1, shell 2, shell 3. But each of the shell has its own sub-energy level. Like this one now is 1s2. It's already occupied for this sodium. This 1s2. This one is already occupied. 8 is also occupied, which is what? Your L. And under your L shell, you can find sp. So you're going to use comma to show that this is one shell. You are now moving to another shell, which is 8. So this one cannot be written as, by the time you break it down, you know it's sp, and it's already filled up. So it's now be 2s2, 2p6. Shell 2, the orbital level of this electron is 2, and the orbital level of this electron is what? 6. Then you use comma to separate it from this one. So this one is the what? The third shell. And in the third shell, you have x to be the first one. So that is what? That is what? 3, which is third shell, x raised to power what? 1. You can see that I didn't talk about p because the energy, the electron is not up to that. But if you add more than that, let's say I have chlorine. Chlorine is 17. So if you break this one down to the old way we say 287, meaning that I have three shells. One, two, three. But each of the shells, we have to break it down to sub energy level called orbitals. So the first shell is already occupied. So we do not be left with what? First shell, 1s2 from that Pascal triangle. The next one is this. In the first shell, you only have s orbital. In the second shell, we have xp. So I have xp. So you have to distribute these what do you call it, electrons according to the what do you call it, the principle, which is 2 6. Maximum of 2 for the x, maximum of 6 for the p. So you have 1x2, we have 2x2, then 2p6 fulfilled. So you still have more electrons, that which is 7 electrons. So the 7 electrons will now go to this place, this is x. So the number one x in this third shell, it will be 3x2. We go into this shell. Then your p. P we take how many? 3. Show you that it is still in your third orbital. The 3p5. So by the time you add all these together, it must be equal to 17. 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, that is 12. 12 plus 5, that is 17. So this is now the modern way of writing the electronic configuration of elements, because they all react using all these orbitals. They use these orbitals. That's why I call us that, okay, they ask you what's the shape of the s orbital. That one is spherical in shape. That's the shape of s orbital. S orbital. They may ask what's the shape of p orbital. P orbital is dumbbell. This is dumbbell. That is p orbital. And they ask you what's the shape of a d orbital. D is double dumbbell. This is double dumbbell. This is double dumbbell. That's for d orbital. Double dumbbell. Double dumbbell. Then they ask you what's the shape of the f orbital. That one is star shape. That one is what? Star shape. I think that one is clear. I think that is clear. That is all about orbital. So you can pick any element. And meanwhile, I'll be talking about this when I get to your periodic table. Because I told us they use atomic number to arrange the periodic table. Because there we can be talking about isotopes, where you have an element having the same atomic number but different mass number. Maybe by the time we get to isotopes, I will explain some other facts there. So this is all about orbital, and I believe this is clear. If you think, I'm not getting this orbital the way it's been explained, the advice I will give to you is to go over the video again, listen to it, because like I always tell people, if you are being told about something, you may not get it at the first hearing. Listen to it again. Listen to it again. Listen to it again. By the time you listen to the fifth, sixth, seventh, eighth time, it becomes the part and parcel of you. And you will forget about it. Because the thing will keep ringing in your subconscious mind. I remain Salumaj. If you have not subscribed or this is your first time of watching my video, please, I have plenty videos now in my YouTube channel. Please subscribe, and we still have more videos coming. If you're in your 100 level, 200 level, like I told us, I promised us special packages for those in chemistry departments, for those who would have applied for applied physics in the College of Medicine. I'm talking about the medicine students, pharmacy students, physiotherapy students, dentistry, dental students, what's your other student again? You have biochemistry students, physiology students in the College of Medicine, and those in sciences. Don't worry, you are all covered. In your 100 level, you are all covered. 200 level, you are all covered. Then maybe with time, we can go to pathology for those in 400 level and what have you. Just keep watching my channel. A whole lot of things It's coming, a whole lot of things. And moreover, if this is your first time, you're in Nigeria, there is a program coming up, and don't miss it. Tell your principal, have they received the letter? Something is coming. Don't miss it. It's called the pivot. The pivot is already being announced everywhere now. But please don't miss it. My student, please don't miss it for anything. Thank you very much. God bless you.